Okay, so lesson 7.2. We worked on some multiplication of exponentials. Today we're going to look at division of exponentials. We multiplied monomials. We're going to find the quotient of two monomials. So let's just take a real quick ponder here. When we multiplied monomials, what do we do with the exponents? Yeah. So if we're going to divide exponents, then you're going to subtract. Okay. So it shouldn't be greatly difficult. What's that?
Does that mean we're going to have negatives?
Yes. Yeah. But you're good with negatives, so that's fine. Simplify expressions containing negatives and zero exponents. Zero exponents. Up here on the number line, or number system here, 10 to the 0 is the base. The base is 10, your exponent is 0, gives us a place value of 1. Anything to the 0th power is equal to 1. Now, why is that? I love showing this. I know it's geeky of me. But to prove this, what I'm going to do is work backwards. I'm going to start with the value of 1. Okay, that's what it equals. And I'm going to rewrite 1 as, let's do 8 over 8. Everybody agrees with that?
Yeah.
Right? Now I'm going to rewrite 8 as 2 to the 3rd over 2 to the 3rd.
Does anybody else hear that echo?
It's probably echoing through that recording. If it is, it's going to be really loud. Oh well. Now, what we're going to learn today is this little trick here where if we're dividing monomials with bases that are the same, we subtract the bottom one from the top, and that would give us 2 to the 0th power. Okay? And we can set that up and do that for any situation. Any base that has an exponent of 0 is always 1. Doesn't matter what it is. If I have negative y in parentheses to the 0th power, because that 0 is being applied to the entire parentheses, that's going to equal 1. Okay? If the negative was not in parentheses with the 0, and this is where you have to be careful, the negative in front of the y is not being applied, or the 0 is not applied to the negative. So in this one, that would be a negative 1. Do you see the difference? The parenthesis on the first one includes the negative, so this value all equals 1. When the negative is not included in parentheses, it's only being applied to the number in front of it, or the variable in front of it. And so you have the negative carrying over. Okay. Redwoods, I would love to see a redwood. Anybody ever seen a redwood? Go to the first one here. You need a drink. Go ahead and do that. The tallest redwood tree is 112 meters, or about 10 to the 2nd meters tall. The average height of a redwood is 15 meters. The closest power of 10 to 15 is 10 to the 1st. So an average redwood is about 10 to the 1st meters tall. So you end up with this ratio of 10 to the 2nd over 10 to the 1st, as far as the tallest type of redwood to the average. So the tallest redwood is approximately 10 times taller than the average one. I'm guessing these are pictures of the taller ones. That'd be pretty amazing.
Get like singers, people, and like how you
Holding hands all the way around it.
Yeah.
Okay, they set this up and showed the division of monomials like they do the multiplication, where they take the 2 to the 7th and they write them all out over to the 4th. And then since this is multiplication, we reduce down. Well, that ends up being 2 to the 3rd. It's just a lot easier just to subtract your bottom from your top. Okay. Same here, t to the 4th over t to the 3rd. Subtract the 3 from the 2 would be t to the 1st. And that's the quotient of power rules. And you can see a couple more examples here where they use variables. C to the 11th over C to the 8th, so we subtract the 8 from the 11. Subtract the 2 from the 5. You're subtracting the bottom one from the top one. It is possible that the bottom one could be bigger. If so that's alright. You end up with a negative exponent on top. Okay. Now they do write in this little bit of extra stuff, no denominator equals 0, just so you know. Not that it would concern you, but technically if either one of those values was 0 on bottom, there would be no solution to this. So that's why they say that. We have an exponent of 3 on our g on top. We have an exponent of 1 on the g on bottom. So when I subtract those, I get g squared. I would take the bottom one minus the top one. So it's 3 minus 2. Sorry, 3 minus 1. It's the top one minus the bottom one. So this one would be subtracting the 2 from bottom. So that would be h to the third. Okay.
Nice.
That's a real simple one, but that's the gist of what this is about. Okay, so try to simplify these two real quick. Shouldn't take much. Can you write in your book?
Yeah, but it's like,
But it doesn't.
It's not as good as
it's weird.
it's not as good as notability, but
It's hard to erase stuff. It's weird.
pretty simple stuff. Subtract the 2, this is x to the first on this x.
Yeah, what if it's
Okay, we'll get to that one. So on this one, then we have y to the third. Everybody good with that?
yeah?
So you could still write these, so what, k to the second, m to the 7th, p to the 0th. You can write it with p to the 0th, but since that value of p to the 0th is 1, it's okay to just drop that, because if this is 1, then does that change what this product is at all? 1 times this would just be this. So you could write it as just that then.
Okay.
Because it's 1 times whatever it is, still just going to be whatever it has.
If the exponent's 1, do you even have to put it 1?
No, you don't have to. That would have been fine. Yep, I wrote the 1 here, but you would just as well have kept it as just x. Same thing. Okay, what are we talking about here? So now we're putting exponents in this deal. Kind of what we already talked about, where we applied an exponent to the top and the bottom. So that's what it's about. Basically, they give you a problem in yesterday's assignment that we weren't ready for. Cool, huh?
That makes
It's
sense.
a failure.
That's true. So it's still an exponential to a power or to a monomial. So we're going to take that exponent, multiply it times each exponent inside. You have 3 to the first and a 7 to the first. So that's going to be 3 squared p to the 6th over 7 squared. I heard the echo on that one.
Allie's ears are going to be bleeding.
Then you have 9 p to the 6th over 49. There isn't any way to simplify that one down any farther. We can just leave that alone.
And you
No? What operation is implied between 9 and 49? If I took away the p to the 6th, what would be implied between 9 and 49? A fraction, which would make what operation? What operation is implied by a fraction? Division. Okay. So we're not going to subtract those because that's division. Do A and D. Let's try A and D. You get those two answers also? Back part of the room, Madeline. On yesterday's assignment, I had told you you could leave it as, if it's 5 to the 13th, leave it as 5 to the 13th. These are just small enough values that I want to go ahead and multiply those out. The values I want you to have memorized anyway. Get any tougher than that? Quotient of powers, calculator we used, we've already done that. So you know that anything to the 0th power is always 1. So, trick question. Looks complicated, doesn't it?
Super complicated.
But it's all, everything's inside parentheses.
So it's one. I mean,
Anything to the 0th power is always 1.
Oh, could we just get a bunch of those questions?
yeah.
One,
Is that
one,
an
one,
option?
one.
I don't know if there's a bunch or
Maybe
not.
one.
Alright, looking at this, let me cover that up.
Yeah, but there could be a negative on the outside.
You have the y to the 0 in the problem to begin with. Could you just, since you have something else with it, couldn't you just write x to the 5th without the y to the 0th and it'd be the same thing?
Yeah.
And then apply your quotient of x to the 2nd. You can do the same thing on this one, where the d to the 0th is 1, so we can just kind of ignore it. And then subtract, so b to the 2nd, c to the 1st. Any problems with that? You girls are kind of quiet right through there. You're with me on it? Great, you're great. Here's your favorite problem in the world.
One.
One.
It's one.
Who knows?
Man, that was so hard.
Good.
It kind of was.
Alright, now, negative exponents. And I know you did negative exponents, because I helped Brett with them a week or so ago.
What?
Yeah. Pre-algebra.
See, but we didn't do that. We don't remember.
We did do that.
We did do that.
I remember.
He actually had,
I remember
for his,
scientific notation. That was the worst thing ever.
That was like the only thing we did with negative exponents, though, was
Was it?
scientific notation.
Okay. Well, we're going to do more with it.
That was cool.
Trying to, let's see what we have here. When do you see a negative exponent? So if you had 8 to the negative 3rd, okay? The negative exponent has nothing to do with the sign of your answer. 0. Okay? All it's telling us is if you have that negative, is we want the reciprocal of this exponential. What would be the exponent or the reciprocal of 8 to the 3rd? Well, what is
Wow.
not quite.
Smart.
As a fraction, 8
One.
to the negative 3rd would be over 1. So the reciprocal of that, if we ignored the sign, would be 1 over 8 to the 3rd. One of the ways I like to talk about this is the way that you can get rid of the exponent, the negative exponent, is think about a turnstile when you're going into a professional ball game or Silver Dollar City or Worlds of Fun or something, and you have to walk through those little clickers. You get up here and you walk through and it clicks and it trips it, and it goes to the next one. The fraction sign acts as one of those turnstiles with the sign of the exponent. So if you take this and we slide it down, when that negative gets to the fraction sign, it trips it and it changes it to the other sign. If I had 1 over 3 to the negative 5th, in order to get rid of the negative exponent, I take this up. Once the negative sign hits the fraction bar, it trips it and becomes 3 to the 5th.
Your ears are bleeding. Every time you talk, it echoes.
I'll have to listen to the video of it when I'm done and see how annoying it is and turn it down next time.
I don't hear that.
I do like
Before you, okay, here we go. Simplify each expression, assume the no denominator is equal to 0. Simplify it so that it gives you positive exponents. Okay? The p to the 4th is already positive and there's nothing to combine it with. The end of the negative 5th is on top, so if I want to make that a positive 5, I have to cross the fraction bar to trip that signal, right? So I'm going to have p to the 4th on top, end of the negative 5th would end up on bottom being into the 5th, and the r to the negative 2nd on bottom, I have to trip it by going over the fraction back to the top would be r to the 2nd. Now, can we combine any of those variables?
No.
Say no.
I've had a question.
Okay, what's your question?
I know.
You can't combine them because the bases aren't the same. So that would be it. I'm interested to see how they write their answer. Yeah.
Boy, so you only take one down when you do the reciprocal?
No, he took.
I reciprocated each part that had a negative exponent, essentially.
Oh,
So-
you don't have to do like the P, you don't have to take the P with it?
No, because it's already positive. It's its own piece, so it can just
Are
stay
you
up
just
there.
like switching it in a circle and making it?
Yeah.
Yeah, because the
Always
simple
do.
is the exact opposite.
When you cross the fraction bar, the sign of it has to change. Okay? If we took this, 1 over 49. What's the reciprocal of 1 over 49? 49. Okay? Well, if I write this as an exponential, that would be that. And if I wanted the reciprocal of it, or if I wanted the reciprocal of it, it would be 7 squared over 1. But if I wanted to make it a negative, hold on, ignore what I just said there. These are the reciprocals. When you have a negative exponent, it's telling you to take the reciprocal of it. Okay, that's why n to the 5th over 1, the reciprocal of n to the 5th is 1 over n to the 5th. So you flip it to get rid of the sign. That's all you're doing. Kenzie? Flip it to get rid of the negative exponent. And if you look at that example hard, you'll see that. And don't get frustrated. Yowza!
Oh
We
gosh.
just say,
Oh my.
are we allowed to just say?
Can you just skip this and not give us a problem that has that?
Can we just
No.
say 1?
Because Mrs. Jackson would get really mad at me.
She would never know.
There are a couple of ways that you can do this. One is if you see things and you just want to do it, you just do it. But if you're someone that's not super comfortable with this, and here's one thing you could do. You could look and go, okay, 5 and 20 are going to reduce. And that's going to be 1 over negative 4. And then I'm going to take what I already have on top, r to the negative 3rd, and t to the 4th, and then I'm going to move all of these up. Okay? And if I move them across the fraction bar, I'm going to have to change the
Negative
sign of the exponents. So this one would become r to the negative 2nd. Sorry about that. T to the negative 7th, and u to the 5th. By getting them all up on top, we have multiplication amongst them all, don't we? So what do you do with the exponents then? Add them. Or subtract it as a negative, right? So r to the negative 3rd plus r to the negative 2nd would make that r to the negative 5th. You have a t to the 4th, t to the negative 7th. 4 plus negative 7 is
-3.
negative 3.
I have no idea how. How'd you
Where did I
do
lose you, Quinn?
1/4.
How do you do the
1/4, I just took the 5 over the negative 20.
And then you just set that like off to the side.
Yeah,
and make-
because it's multiplication, I just set it aside and multiply it by everything else with it. Now, do you have to do it that way? No. Another way that you could. Okay, it's true. You might want to get rid of negatives. This problem doesn't tell us to one way or the other. However, if you were someone that wanted to get rid of the negatives, then you could combine these a little differently. Still get the negative 1/4 by reducing that part. Now we have an r to the negative third on top and an r to the second on bottom. If you don't like this negative here, you could bring it down. And what's it going to become?
Positive 3.
R to the positive third on bottom, right? So you'd have r to the second and an r to the third on bottom would make this r to the fifth on bottom. And then if I were to subtract the 7 from the 4, that'd give me a negative again, right?
Yeah.
T to the negative third. Or I could take the 4, bring it down, make it negative 4, and have t to the third on bottom, subtracting the 4 from the 7 on bottom. And then that u is already down there. Isn't this and this the same things? You have a negative 1/4.
I don't know.
You have a negative 1/4.
Yeah.
Yeah.
Isn't r to the negative fifth the same thing as if it was 1 over r to the fifth?
I have no idea. Yeah.
Let's break this down. Break it down to negative 1/4 times 1 over r to the fifth times 1 over t to the third 1 over u to the negative fifth. Isn't this and this the reciprocals idea?
Oh, yeah.
This one? That one, Corey? All I'm doing is showing the relationship between the two ways that it's the same thing. Go ahead.
Why wouldn't you just leave R, T, and U by itself like you did when you had it on the top?
You could.
Good?
I'm just showing the relationship between the two.
Okay. But like, wouldn't that mess? Because like, if R, T, and U were by itself and it was 1/4 times R to the fifth, T to the third, and U to the negative fifth, that would be different then.
Well, that's why I put them on bottom on this one, because they're on the bottom of that
Yeah,
fraction.
they're on the bottom of that one.
So technically my 1, maybe it'd help if I put my 1 right here.
Like that's a fraction.
1 over all of that.
All over
Handy.
Now what did they do? They wrote them all as, Kinley? They wrote them all with positive exponents. Okay? So from this, I would have moved my u to the negative fifth up. Or if you had this situation, you'd end up with the u to the fifth on top by itself, with the 4 r up to the fifth, t to the third on bottom. I think, I don't remember exactly, but I think that the book will say, write your exponentials with positive exponents or write them with negative exponents. Put them all in the numerator or put them all in the denominator. It will explain where it wants, how it wants you to write your answer. Because there's multiple ways to do that. What was the process they did? They moved everything up, didn't they, like we did to start with?
Negatives back down.
Okay, and then got to where we got, and then moved those two back down. So I want you to try this one on your own. It's looking like we probably won't have homework. That's not good.
Try that one. Okay.
Try that one.
We'll try. That's all I promise. How are you doing?
Because the answer's right there.
Oh wow.
Well,
Okay.
yeah.
You know
But
what?
you can still try to work it out yourself.
Where?
Subtract the exponent that's on bottom from the exponent that's on top.
It's way over. I get this. It's gotta be some time.
Keep in mind, you're subtracting the value on bottom from the one on top. If your one on bottom is a negative, you're still subtracting the negative value.
I'm gonna go with that. That's right.
Mm-hmm.
Got it.
I actually think it's right.
I think I have the answer. What you get?
That.
It's not what I got.
I think it was.
I just added that.
I'm just kidding. Just stay with me. Please just don't.
Sorry, did I get mine?
5 minutes.
Is that a I drew an eyeball?
Because I wanted to.
I'll draw an
So I'm going to go 1/5. This would be a to the 5th.
That's my eyeball.
Let me write 1/5 and then put the stuff where it's supposed to be. A to the 5th is on top because of plus plus.
Yep.
And then 3 minus -1 again would be b to the 4th. And then plus plus would be c to the -1st. But I'm going to go ahead and move that down to put it like the book had been doing it, where the positive exponents. So this is going to go down and become c to the positive 1st. Do I need the 1 out front? Do I need the 1 on the c? Technically, no.
What'd you get? Oh,
I got that right.
Should have.
Where's the S?
did not get that.
There's not. That's a 5, silly. 1/5.
Yes.
Just because my handwriting's
How'd you
terrible.
get B to the 4th?
Why is it b to the 4th?
How did I get that?
It was 3
Oh.
minus -1 becomes plus plus.
Wait. I did that way wrong. I got 1.
This is like something Patrick.
Wait. Will you go back for a second?
Yeah.
Okay.
Order.
No, I got that now.
Try B.
Uh-huh.
Try B.
Okay, I'll try.
I can't wait.
I don't even want to do this.
Okay, so got 32/4, which reduces to
8.
1/8.
No, 1/8.
8/1.
What?
8/1.
Oh yeah,
32.
sorry. I wrote it
You
down.
wrote it down.
So
Like
then
how
what do
it was
you do?
supposed to, and I said it backwards. I'm sorry.
You got it.
Got.
Oh, dude.
I'm gonna bring the 8 down.
Put the 2 up. No, I got 8.
Sweet, I got it.
How do you do that, Corey?
You just have
32 divided by 4 is
8.
8. Now I have an a to the -8
Okay.
minus, what's the exponent on the bottom?
3.
3. So you have -8 minus 3, which
That's
is
-11.
-11. And then the 3 on top minus the 5
-2.
would be b to the -2nd. And then -4 minus -2.
6. No, -2.
Plus plus makes that c to the -2nd. And then to write it nice and neat and just
Wait,
move all
put
those
the
down.
8 over.
I have to leave it on top because if I were to move it down, it would have to become 8 to the -1st. But so it's just a whole number value, leave it alone. Okay? Why are those other classes letting out at 2:30 or 1:31 instead of 1:32?
To confuse you and not give us order.
Hey, I don't know which one it is. You do have seminar today, don't you? I don't know which one it is, but you can find quotients of exponentials in IXL and practice a little bit to get a feel for it if you're doing nothing else. Okay? All right. I guess we'll go since Arlie and Quinn are leaving.
Yeah, we don't have to audition,
What?
but
we can go.
if